Yeah, today we are going to discuss about containers and DockerHub, Azure Container Registry, Container Instance, and a few demos. Uh, First of all, uh, what is container? Cont- and container basics and benefits of containers, and we can see the docker commands, few docker commands, and how to create the image, and how to create the contain how to run the container by using image, and what are the registries uh, available uh, in Azure, and in public registry and private registries, and we can see some demos. I think started right. Yeah. Okay. Before going to containers, there is a virtualization. Um, Virtualization is a concept to virtualize the computer resources, total computer resources, or we can virtualize the only operating system. Virtual machines are running on the hypervisor. Here there is a infrastructure, server infrastructure. On top of server infrastructure, there is a host OS. On top of host OS, there is a hypervisor. Hypervisor will create the virtualization of OS and resources. So we can create the multiple virtual machines by using the hypervisor. So each virtual machine is having the uh, uh, operating system and memory, CPU, and application disk space. But coming to the containers, it's the same thing. Server infrastructure. On top of server infrastructure, there is a host OS, uh, but there is no hypervisor. Directly, container runtime will run on host OS to run the container images. And there is a volume. It is shared between the volume or disk space. It is a shared between the multiple images, multiple, not images, multiple containers. Uh, so here we can and uh, here we can leverage the space, disk space, and memory. But here is guest OS and memory and CPU all are isolated. We cannot share between the multiple virtual machines. But in containers, we can share between, we can share the resources between the containers. And initially, containers started with Linux operating system. Um, Recently, a few years back, they have started building the Windows containers also. Uh, but with Windows containers uh, are, as of now, Windows containers are heavy. It's not lightweight. Linux containers very lightweight. Okay. Docker is having a specific architecture. Docker host, Docker hub, and some images, some containers. Actually, this is a Docker hub is a centralized repository. Is a registry to host to distribute the images between the developers, between the organization. This is the Docker hub is a famous uh, popular Docker registry. It will maintain the public and private images. Uh, and if you see that it's several components. Docker engine is having the several components: Docker client, REST API, Docker server, images. It all consists of it all become one component that is a Docker engine. Doc we will communicate Docker client by using Docker CLI command line interface, and Docker it will send the image. It will send the request to the REST API. REST API will send the request to the Docker server to pull the image, existing image, to pull the image, to download the image to the our local space. Docker host is nothing but the is a operating system where Docker server Docker engine is running. That is nothing but the Docker host. Image, and what is the difference between the image and container? And image image is a uh, image is a set of static container. Static container, we can build the image by using this set of instructions. The set of instructions is called as a Docker file. Container is nothing but the running image is called as a container. We can run the uh, several containers by using the same image. We can see in the demo. Yeah, these are the Docker commands. To see the Docker version, there's a Docker version command. The Docker info, display the system information, Docker information, Docker images, and to get the list of images in the Docker host, Docker login, to log into the Docker registry, that is for DockerHub, to Docker logout, log out from the Docker registry. Docker PS, it will give the list of running content, running images in a Docker host. Docker pull, to pull the image from the registry. Docker push, to push the image to the registry from Docker host. And Docker run, and if we have the image, in our local, it will run the command, it will run the image, it will create the container. If you don't have the image in our local, it will pull the image from the Docker registry, and it will run the container. It will run the image. And Docker kill, to kill the containers, we can use the Docker kill, either container ID, or first four letters or four digits of container ID. Docker start, to start the container. Docker stop, to stop the container. And Docker stats, to statistics. Where is that? And Docker RM, RM is used to remove the container. And Docker RMA, to remove uh, images. Docker tag, to add the tag is to the existing image, so it will create the another version. Docker exec, it will run the command inside the container. Docker restart, it will stop and start the containers. Docker rename, to rename the container. We can see the demo, and we can go come back to the presentation later. I will switch to the my uh, virtual machine. Just a moment.
Yeah. Hey Rajesh, quick question.
Yeah.
So the image, there's an image in a container, right? The image will have just the host, OS image, or it could have more than that.
It contains everything.
Within your
Yeah, image is isolated. If you see, image is operation system, network, and ports. It's isolated from the existing OS. It contains the
Okay.
how we can write the Docker file. Based on the instructions, it will create the image. Yeah, not only operating system. Not only operating system, it will. I will show in the demo. It has its own isolated environment, isolated OS, isolated data, isolated security, isolated network. If you see,
Gotcha.
I will show you in the demo. I'm going to start my VM. Just
Okay. Can you explain or show how you use VM? Just a regular
Just a
VM,
regular
right?
VM, right?
Or you
Or
have to
you
create
have
a
to create a
different way?
different way? No, no, this is a regular VM from Azure. I created the one virtual machine in the Azure. This is the
Okay,
regular VM. Okay. Yeah.
okay, that's
Okay,
the one.
that's
Yep.
fine. Yeah. Yeah. Uh, I'm using WSL Windows Subsystem for Linux to run the Linux commands in Windows. It will. I
Okay.
have. Okay. I have WSL editor. It will. I can connect to Ubuntu. I can connect to uh, PowerShell. I can run the. It will support the all the command line editors. And if you okay, if we can switch to browse. Uh, yeah. No. Where is my? Yeah. This is the one. This is the one I created last. Okay. This is the one. And okay. Initially, it started with Linux, but we can install Docker any operating system, a Mac, Windows, and Linux. There are a set of instructions to install the Docker. If you suppose if it is a Windows 10 professional or above version, we can install the Docker desktop. If it is a if it is not a Windows 10, it is a older than Windows 10. We need to install the Docker toolbox. Uh, and if it is a Linux OS, we can install the Docker for Linux. It will support the more than it will support the all the distribution of Linux systems, Linux distributions, CentOS, Debian, and Ubuntu. There is a set of instructions. Each Linux machines we have. If you suppose if you go to the Ubuntu, no, it's a CentOS. If you go to the Ubuntu, there is a set of instructions. We need to install the app sudo apt-get is these commands. Then
Mm-hmm.
we can install uh, this is the community edition. If for development, community edition is fine. If for production, we need to install the Docker enterprise edition. If it is a with Windows, we need to install the Docker for desktop. Uh, just double click on exe, it will install. Suppose if it is a before Windows 10 older version of Windows 10, we need to use the the Docker toolbox. Suppose if it is a Mac, we need to install the Docker desktop app. We need to drag into the uh, App Store. Then it will work. So currently, I'm using the Windows 10. In Windows 10, is a straightforward exe. Just we can download the uh, Docker Docker desktop. and we can install. Once you install, you can see the Docker desktop, and after that it will show you the Docker desktop is running. If you see that here, there are, it is supporting, actually my OS is my OS for the OS for the this operating system is uh, Windows, but it will support both Linux and Windows containers. I can switch from Linux to Windows, Windows to Linux. Currently Windows containers, I'm switching Linux container. It will switch. It will restart. It will restart. Yeah, I can see the settings here. I can see. I already connected to the DockerHub. So this is my user, and if you see the settings, this is the settings. It is going to open. These are the settings we can, and whenever uh, we'll log into the system, we can start the Docker desktop. We can enable here, and if you are working with Kubernetes, in the coming session we can discuss about the Docker orchestration. We'll discuss that topic. Suppose if you want to enable the Kubernetes, we can enable the Kubernetes here. It is still restarting a container type. Okay, let it be. And suppose I have Docker uh, Docker desktop in my system, Docker version. What it is saying, it is a client and server. Client is so and so version is using, API version is so and so, and server. So this is the Docker host. This OS is the Docker host where the Docker engine is running. So this is the Docker engine. Suppose I connect to the Ubuntu. In Ubuntu also I installed Docker engine, but it is not connecting to the Docker server. So I cannot suppose if I run Docker engine, sorry, Docker version, there is a quite if you see the difference. One moment,
There is no server.
if you see the difference, a client is installed. Here a client is installed and server is also installed. Sorry, server is also connected. Here problem is in this Docker DOM is looking the file in the this volume where run Docker sock. This file is not exist, so it is not able to connect to the Docker engine. So Docker engine or Docker server. So if I run the commands Docker pull or push, it will not do anything. So if I will minimize, I will switch to the sorry, yeah. If you see in this diagram, client is installed. It is trying to send the request, but Docker server is not able to receive. The Docker server is not connected. So in this Docker host, we are not able to get the images from the hub, and we cannot push the images to hub. So if I go to the here in Windows, I install the Docker engine, Docker desktop. It install the Docker client and Docker server. So I'm able to push. So currently, I will run few commands before going to the next topic and next presentation. I will run few commands and I will show you what are the things we are going to do. Uh, just a moment. Docker. First, I will run what are the images are there. Images. So there is a lot of images. I these are the images the last time I ran. I will one moment. How many images? 1, 2, 3, 4, 5, 6, 7. Total 7 images are there. I will kill all the images. Or okay, let it. Okay, I will kill all the images. I will. That is also.
Or just show one. Yeah.
The Docker RMI. Suppose this is the tag latest. This is the dev tag. This is the version. Suppose I want to delete. I can use the image ID or I can use the this name also, image name also. I'm using image ID. You no need to give the total image ID. Even 4 letters is fine. D681 is fine. It will find and it will delete. And it will delete for image multiple repository. Let's say multiple repository. Okay. Before, okay, it is saying that it is not able to, Docker DOM is not able to delete because another container is using, or another images or another container is using this image. So that is the reason it is not able to delete. So what I will, okay, Docker PS will give all the containers. So there is no running containers. Docker PS minus A, these are the containers, but it stopped. Currently not running. These are the previously it started, but it stopped. So what I will do, there is a there is a command. I want to remove the I want to remove the existing container rm minus where is that 94. I will use 94 yeah. Yeah. Docker rm 94 b, no such container. I will do one thing. There is a command docker delete all the commands, all the ps minus a q. What exactly it means? Minus aq at least. Okay, first I will run this command. I will show you what it will do. Docker minus aq will give all the container IDs. So to remove the containers, I need the ID. So I will use this command docker rm dollar dollar docker ps minus aq. I deleted all the docker rm no, rm no docker ps minus yeah. So there is no running containers, or there is no containers in docker host. I'm cleaning existing images also. Docker images, there are certain images. Okay, docker rm, I'm using the same command. Okay, docker images minus eq. Fine. I will do the same command docker rmi rm for remove the container. Rmi means remove the images. To remove images, images or images. Uh, this is the one deleted. Yeah, okay. Minus f. Okay. Docker images minus aq. There is no images. There is no images. So it is clear. It is clean now. So there is no images in my local. There is no containers. Now what I will do, I will pull the image from the DockerHub. Okay, Docker pull Linux. And if you see the images, suppose I will log in and Docker up.docker. This is repository. Suppose if you want to explore nginx, This is the DockerHub registry. If you see this is the image nginx. This is mainly used for the website hosting, for load balancing and reverse proxy. There is a image information, and if you see how to run the image and all, and we need the port number, and we will go through all those things. This is a command to pull the just to pull the image. This is the command docker pull nginx. If you see the tags, there are different tags. If you didn't specify the tag, it will pull the latest image. If you specify the tag, suppose tag name is so and so tag, we need to specify nginx colon view available tags. It's the same thing. If we need to specify nginx colon specific tag, then it will download. uh, if I specify the only pull, it will pull it. If I run the image, okay, I will show you both the things. Docker pull nginx. I'm not so, but by default it select the latest one and it pull the image. It is pulling the Linux image. My version, if you see, yeah, currently, okay, if you don't, we don't know, just Docker version. So if it is running Linux, uh, my client is running on Windows, Docker engine is running on Linux. So it will run the Linux images. Clear? So what it did, it Docker pull the image, it connect to the DockerHub and download the image, and it image size is you can see the minus, it's a 133 MB. So we didn't specify the any other switch. Now we are running the image. Docker run nginx latest. If you don't specify the uh, tag, it will run. Okay, we'll specify the tag. So I cannot do anything. This is the interactive mode. Until unless it is started, ready for startup. Control C. Okay, and now Docker PS. This is started. I didn't specify any port number. It is running on 80 port. It is running on 80 port. This is, I didn't specify the name. This is the container ID. This is the, I didn't give the any name. So it create the random name. Awesome night nightingale. Uh, Name as awesome underscore nightingale. So it is started in 17 seconds back. Okay, now what I will do, I will create the another instance. Run -d. -d means hyphen d or -d. It's a detective detactive mode. IT means -IT means interactive mode. -d means detect detach. -p. I'm giving the port number 30, port number 303080. If you see 3030, this is the, okay, better I will explain this one first, and I will go to the port mapping. So every container its own network, every container its own network, its own storage, its own operating system. But if you so now I'm specifying 303080 ng as container 2. So I'm going to 303080. I'm specifying name now. name nginx nginx container, yeah, nginx2 and nginx. By default it will take the latest. If I didn't specify, by default. Now what it is doing, this is a detach mode, and P means port number. I am specifying. There is some switches. E means environment variable, P means port number, V means volume. There is we will see. Now I'm running this one. So it immediately started. It didn't give anything. Now I can see the Docker images. Sorry, Docker PS. It's a typo. Docker PS. This is the name nginx2. So this is running on port number 303080. So 3030 is okay. Let us see. I will open localhost 3030. This is 3030 port number in this operating system. 80 is in a container, port number in container. So now I want to I want to run some commands, or I want to see the file system, what is there in this container. There is a command docker exe exec container name, in interactive mode, container name, where is the container name or container ID also fine. I'm giving container name nginx2 interactive and shell. Now I'm in a Linux operating system. Now I'm in a container file system. This is not a file system in my operating system. If you see, there is a this is not the file system in Windows. This is a file system in Linux. So this container is using the Linux operating system, and this is the, if you see the folder names, this is the Linux folder structure. And now I didn't this container is running in port number. If you go to the this container is running on port number 80, and it is mapped to the 3030 mapped to the 80. I'm creating the one more container. So each container its own port number, and we can specify the same instead of we will do that demo also. I'm going back from this one, control C or exit. Okay, now I'm in a Windows file system, docker ps. So three are running now, docker. Now what I'm going to do, I'm creating the one more port number, docker run detach mode. What is the port number I'm using? 4040. I'm using the same thing, 4040. I'm using the okay. It is very fast, even less than 1 second, because the same I'm using the same image. It is not downloading any image. It is just create the one more instance. It's very fast. A fraction of seconds it created the one more instance. If you want to see the docker ps, the another instance is created. If you go to the browser, 4040. I'm running this one. It is running. Okay. 4040. Yeah. So same image is running in another port also.
So basically, you install one image and then you can create multiple instances.
Yeah.
And run those, and then kill them. Okay.
Yeah. Yeah. So yeah. Now if you see that this is the uh, output, but it's not clear. So I'm creating the one format. There is a format docker ps docker p docker ps will give the container IDs. Docker ps format. Yeah. Now it is giving this IDs. I'm adding all the uh, I'm adding the one environment variable. Format. Okay. Now I'm giving the docker ps format dollar format. Yeah. Now much clearer. So this container is running on 4040. This container is using running on 3030, and this is port num. This is the name nginx container name. This is container name nginx2. This is the default without name I created. Now I'm creating the another instance with three port names. Same container with multiple ports. Suppose this is the command I used. Now instead of using, I will command this two. Now detach mode and P means port number. I'm using three multiple port numbers. I'm using 5050. Six zero just for okay. I'm giving ng container 3 nginx 3. Okay, run. It created. Now I will run the command. If you see here, container is created by using the nginx image, and this container is running on port 5050, and it mapped to the 80, and 6060 in this is a port number in my local machine, and it mapped to the 80 port in container. If I run the browser 5050, both will work, and 6060 also will work. Okay, so it means that if I switch to the my diagram, so we can map multiple port numbers to the same uh, so to the single port number in the single container. Instead of multiple containers, we can map the port number, say single port number of single container. So we can map one to
What
one.
is the advantage? Why do we want to do that?
This instead of creating the multiple instances, we can create the one container, and we can map to the multiple ports. So we can access through 6060 and we can access from 5050 as well. Same container.
So before, whatever we were deploying on two different containers, now we can deploy the same thing in one container and then use different
Yes.
ports to access those, huh?
Yeah.
Oh, gotcha.
Exactly. And one more thing, now containers are dispose easily. We can dispose the container, we can remove the containers. If you see that, now we have 1 2 3 4. Suppose each container is having its, where is it? Command. Yeah, suppose I'm using nginx3. I'm going to share ls minus al. Suppose if I place some file or something, this is once container is disposed, this data will be disposed. So this is not permanent, this is volatile memory, or so containers are, we can, this is not, yeah, we can keep the data inside the container by using the file system, but as long as container is running, we have the data. Once container is disposed, or maybe container is stopped, we don't have, we cannot connect to the data, we cannot retrieve the data. So there is two options to get the data. Either we can keep the information in the container file system, or in the either we can mount the volume. Volume means, volume is nothing but sharing the data or sharing the files or folders to the container. The container host files volume we can mount to the container volume. So Docker, in the Docker, suppose it exit, suppose this we have volume here, we can share the volume of Docker host to the Docker container. Even Docker container is stopped or disposed, we have the data inside the data is exist in the uh, Docker host. So we can share the uh, data between the containers, either sharing the container file system, or we can either mount the volume, uh, and we can share the data between host and container, or between the containers. So that is also possible. If you, I'm going to run the, yeah, we can see the data. One moment. Same data. Suppose cd, no, I will run another command. Where is that? Yeah, cd user, share nginx ls minus a cd ls minus a cd, this one, see, you can see the data, same image, same content, whatever we are seeing here, same content. Suppose go to this one, 50x HTML. Let us browse that one. I think that is not the default page. This is the default page. Uh, so, error occurs. What is the page? What is it? It's the same page. Okay. Now I'm going to create a one. Suppose if I exit, Docker RMI RM uh, 09098 you cannot remove because the container is running. I want to remove forcefully. It's removed. Now now that image is not there anymore. So if whatever I created, that data will be lost. So if you want to share the images between the containers, there are two ways. Sorry, share the data between between the containers. There are two ways. If I switch to the my diagram, volume mounting. Suppose if I create the file within the container, sorry, there are two ways. Suppose in host we have two containers. This container is running on this port. This container is running on this port. We can share this data to this data. We can share this file from host to this data. These two are possible, but most preferable way is this one, because if you share this one to this one, as long as this container is running, this container has data. Once this container is disposed, we don't have data. So this is not a preferable way. This is preferable way. Was keeping mainly container is running the images, not intends to storing the data. Okay, I will show you next one. Just a moment. It's clear. Now I will download the Redis cache. Docker run. I'm not pulling image. I'm just directly running the image. Detach mode port number 220, maybe I will 2500. 65 name. No. I think port number is 25. It's okay. 6379. This is the port number for Redis cache. But it is not able to find the image in my local, so it is pulling the image from the DockerHub, and it is after that it is running the image. I'm using the Docker format. This image earlier it was not there. Redis image downloaded from the DockerHub, and there is one more command. If you observe that this command Docker entry point, we will see what is the Docker entry point in the coming slide. Every container is having the Docker entry point. This is the command. After downloading, this is the command to start the container. If you so Docker Redis Docker image Redis image downloaded from the DockerHub, and it is running in port number 6379. Now I can see the log. If I Docker logs, Docker Redis one. it's not logs. I think that is wrong. Uh, yeah, this is the log. So it is now accepting the port. So this is running now. What So now this is ready and to create. So now I will run the Redis CLI commands inside the container. I will in my local there is no Redis CLI. There is no Redis CLI. I will go to the Docker. I will go to Redis container inside, and I will create the sum of keys and values to store to purchase the data inside the Redis. Redis Docker X execute interactive mode Redis one. Okay. Now I'm inside the container. Inside the container, I will see ls. This is not the file system in my local. This is a Linux file system. I will run the redis command CLI redis. Now I am in a different port 127.0.0. This is not my port number. I will show you. This is not my port number. If you 127 is not my port number. Okay, this is inside the container. Inside the container, Docker is having the Redis CLI. Now I'm going to create the. I will ping. Okay, Docker CLI is working. I'm creating the some command name value. Now I'm going to. I will insert the some command counters. Okay. Get name. Okay. Get okay. So what I did, I will connect to the Redis container one, and I mean inside the container I added some values in the Redis container one file system. Now I can see the so exit. I'm out of. Now I am in. Sorry, I'm exit from the Azure. Redis CLI. Now I'm exit from the container. Now I will create the another container. So okay, I will create another container. I will create another container, Redis container. Uh, is that Redis container 260 and Redis container 2. Okay. Now it is very fast. It is not pulling the image from the DockerHub. Now what I am going to do now, Docker exe minus interactive mode and Redis 2. this is wrong one. Interactive mode. Yeah. Now I'm inside the container. Now I'm opening the Redis CLI. It is running different port inside the container. 6379 different port number. Okay. Now I'm trying to get the data. Whatever data inserted in container one, Redis container one, get name. It will not give anything, null value. Get null value. So this file system is different. I stored the data inside the file system one, inside the container one. So I will exit from the container. Okay. Now I will go to the container one, inside the container one. Okay, that is CLI. Now docker get name, get hashtag. So container is still running. Still I have data. Now what I'm going to do, I'm going to exit now. Exit. I'm creating the one more container. I will link the container one data to the container two. So container three. Docker run interactive mode. I'm not running in detached mode. Now I'm running in interactive mode. Run interactive mode -p. I'm not running in any port number. I'm linking Redis 1 to Redis 2. First of all, I will see just a moment. Redis 1, Redis 2. Okay. Now I'm running Docker run -ip. I'm linking Redis 1 to Redis 3.
So what is the reward in RM?
That is switch to remove the container. But just a moment. Unable to find the. Oh, I didn't give the specify the Redis. This is the image name. Then I'm running in interactive mode, shell interactive mode. Yeah. Redis CLI. It is not able to connect, right? And now Redis CLI. CLI. Yeah, now it is connected. So I'm linking Redis one image to the Redis with name Redis. So that is the reason it's connected. It is running on the same port number, but it is showing Redis and it is 6379. Earlier also it is running on 6379 only, Redis 1. So it's the same port number. If you see that, okay. Now I
What
will
is the
try.
minus H switch?
Sorry,
You have
You have
minus
minus
H
H
switch, right?
switch, right?
minus H means shell. Uh, um, actually, this is the Redis CLI. Minus H is a shell. I'm giving this command, Redis command. This is a link command. So it is connect to the Redis in the shell.
Gotcha.
Gotcha.
And now I'm running the get name. Now I got it. So it is map. It is now I'm linking the Redis 1 to the Redis 3. Redis 1 volume to Redis 3. This is one way. This is linking is one way. There is a one more way is the volume minus get name get yes. So I'm exit from the container. Exit from Redis command line interface and exit from the shell. Okay, now I'm in Windows. Docker. Now I'm going to kill the I'm going to stop the Redis 1. Docker stop Redis 1. Yeah, stop. Now this is Redis 1 is stop. Redis 1. Now it is not showing. Redis 1 is not showing anymore. Redis 2 is there. Yeah, Redis 2 is there. It is not showing. Suppose I want to see minus. Yeah. Now Redis 1 is stop. This is not running anymore. So I want to uh, now I'm going to run Redis 2 and whatever command. Okay, instead of going this command, I will use interactive Redis 2. Yeah, that's correct. Okay, shall open. Okay, then Redis CLI minus H shall. No, okay, that's correct. Okay, this is Redis CLI minus H. Redis. It is not able to connect because that service is stopped. So no, it is not. Earlier I was able to connect, but now I am not able to connect because that container is stopped. So exit Docker start Redis 1. Started now. Redis. Okay, this is wrong. Yes.
Yeah, started
Yeah,
the
sorry,
Yeah,
Redis.
yeah, yeah, yeah. I think not Redis CLI minus H Redis.
You started
You
Redis
started Redis
1
1
and connecting
and
to Redis
connecting to
2.
Redis 2.
No, I'm inside the Redis 2 container. So that is correct only. Just a
Okay.
minute. Okay. It is not started yet. I don't know. Just a minute. Exit. Docker. Uh, yes. Yeah, both are up and running.
Okay.
Okay.
Entered. Redis. Message. should connect. And let us do one thing. Link. This one. No, it is not okay. Yeah, this is the problem if you maintain the volume inside the container. Yeah, that is the reason this is not the suitable way to maintain the volume inside the container. We need to keep the volume outside the container. Uh, Volume or data. How we will specify? Suppose we need to specify the inside. Suppose here we are specifying the Redis data. We didn't specify the data. Now we can. Okay, now I will connect to the another image. I will docker run detach mode detach for 5432 5432 5432 then volume Postgres data colon back link Postgres. I think it won't work. I know. I will show you Postgres SQL SQL data name Postgres maybe Postgres one. Yeah. Mm, Postgres means Postgres. Yeah, this is wrong. Yeah, volume instead of volume I gave the equal to volume. Okay. It is download the image from the DockerHub. Yeah, download the image Docker. Yes. Minus format. Where is it? Postgres. So it is not running. Basically, it is started and exited. So it's not running because volume data. This is not available in a that is not available in my local. This I gave the path, but this path is not available in Dockerhost. I'm okay. I will in the Windows subsystem there is a feature WSL. Way to show. Just, yeah, this is the one. WS. Yeah, I can share this data instead of why it is stopped. If I see that I'm trying to share the some. Oh, this is also wrong. I think this is spelling. Yes. Yeah, it is already there. Yeah. Okay. Docker. Yes. Now it is not running. Yes. Minus here. Yes. It's stopped. Okay. Okay. Why it is stopped? Because that data is not available. I will find the WSL. I'm giving this instead of sharing that data. I will give this one. Where maybe dev use. You want to go to this directory? Just a moment. Just time I connected. And this actually what is the problem here? Container is Linux container. It is not able to access the Windows file system. There is a way to share the WSL file system in Linux format or Unix format. I'm trying to give this path instead of this path. That path anyway. I know this path doesn't exist. if you see that this path that doesn't exist, where lib that is not exist in my local, so I want to give in this path. See mount cd any of these one, but okay, I will try. Uh, mm, it's already there. I will change to, but I don't know it started because I know this issue. Uh, yeah, it's a problem with the sharing file system from my local. There is a way to share the Windows subsystem Linux file system to Linux containers, but I'm not able to find this path in Windows um, in Windows first. Uh, I will. That is the reason I'm not able to connect. I will share this one later. Uh, okay, I will go switch to the okay presentation again. Yeah, benefits of Docker it will provide the uh, encapsulated content for application data and dependencies. It will build the application data and underlying OS, file system, ports, and security related stuff. Everything uh, map everything isolated from the current OS. So everything is encapsulated, hardware agnostic. It will run on a current OS virtually, but there is no dependency between container OS and host OS or host operating system. Uh, Content isolation as I specified, resource network and memory, everything is independent from the uh, hosted system. We can automate by switch on start and stop and uh, 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 we can create the images for our application. We can use in continuous integration and continuous deployment in a faster development way. Uh, Actually, Linux containers are as of now Linux containers are lightweight containers. It will quickly start and quickly move from one Docker up to you can quickly download and quickly move. So it's a quick start. Within fraction of seconds, we can create the n number of containers from the same image. So, or we can download and we can. But coming, if you use the Windows containers, as of now, Windows containers are heavy. It will download the Windows OS inside the container, so it will heavy. So it will stay. It will take some time to download the image, but after that it will be fast. Going forward in production version Windows 2016 or 2019, Windows is officially supporting the containers in Windows operating system. Separation of duties. Developer will completely focus on code. Upstream operation team will focus on the infrastructure. There is no dependency. Even during the release, nothing is related to the development, but developers will stay from development team. Some people will stay in entire development process or to support the operation team, to support if any files are missing or to ensure application is up and running or release is going to smooth. Once if it is if once it is built, if it is running in my machine, it should run in every machine. It should run in test machine. It should run in PM pre-production mission and production mission also. So only for connection string or some environment variables are changing. So developers are not required. So the operation team can manage. So we can strictly isolate the duties. Otherwise, during the development or during release, during testing, during the build time also, developers and ops team should work together. It's a additional efforts. Build once and run anywhere. If once we build the image uh, by using the Docker file, it should run in any machine. It's the same thing. If you build the image with all dependencies, what are the dependent underlying operation system, all underlying files, what are they required, we can build it and we can give it to any, we can run it in any machine. So it will give the if it will give the confidence to the developer or operating system, operational team. So once it is running in any environment, it should run everywhere. We already discussed about the port mapping, file sharing also we already discussed, but I'm not able to show the demo because I'm not able to find the WSL sharing uh, WSL in Linux format, the WSL file system in Linux format. That is the reason I'm not able to share. This is same format. If you see mount CD WSL, it's the same format. WSL Docker desktop mount. It's the same format. Mount CD WSL. I'm able to access this folder in Windows, but how to share this one? I'm not earlier I used, but I didn't remember. So that is the reason I'm not able to show the demo for this one. I will switch to other things. Uh, Docker image. Yeah. To create the Docker image, we need the Docker file. Actually, once we Docker file is it's a plain file, plain text file with set of instruction how to create the container, how to run how to create the container image. So it is having the set of keywords and it is following the layer architecture. Once and it is following the layer architecture and stages also. Once a layer is created, it is read only. We cannot change the layer, and we can build on top of that layer. We can create another layer, and it will support the multi stages also. Docker, if you see this diagram, Docker host is nothing but a physical computer where where Docker engine is running. So in this here, Docker host is my operating system, my host operating system. That is a Docker host. Uh, Docker image. Image is a standard unit shippable standard shippable unit uh, to run the software to run the Docker containers. It contains all the dependencies. Docker container is a running instance of image. If you have image, we can create n number of instances. uh, Docker register 5 is a registry. So in the source control, suppose in the source control we have the Docker file, we can read the Docker file, we can get the Docker file, and we can build the Docker image by using the Docker build command, Docker build -t, and we can give the Docker file, it will create the image. And after that we can push the Docker image to the any container registry. Here I'm using ACR, Azure Container Registry, or there is other container. Most popular container registry is for DockerHub. DockerHub it will maintain public and private containers, container images, and ACR is a container registry in Azure. To store the images in Azure, we can use the ACR. After that, we can pull the image from the container registry and we can run the image. uh, uh, this is this is the these are the samples how to build the image, uh, how to build the Docker file. If you see that there is some keywords from this is the Docker base image as here this is single stage, there is no multiple stages in this stage. If you see that there is a multiple keywords from working directory, copy, run, copy, and there is other commands. So expose, expose is a port expose. To create the port we can use the expose. In the first command I'm not using any port number, just I'm using the uh, .NET Core image as a base image, and after that I'm creating the working directory, source, and copy files from my local directory to this directory, working directory, run .NET restore to restore the NuGet package. NuGet package all the dependencies, the dependent libraries. Uh, I can we can use the .NET restore if it is a .NET application, and copy .NET means copy the current directory to working directory. Dot means current directory in the image. Working directory source dot. So I'm changing the working directory from it's the same it's the same directory, and run the .NET build. Uh, it is giving I'm building the building the CS project in the release configuration, and copying the files output files for this build into the app build. So it is copying the all the files into the app build. In the multi-stage, not only one stage, I can creating the multiple stages. This is the base stage, and this is the build stage. This is the another stage. This is the final stage. I can use the output of the output of the previous stage into the current stage to publish the application. I can show you, but how to create the Docker file? We can create the Docker file by using the Visual Studio Code, or there is some samples from the ASP.NET Microsoft Docs. We have some samples. We can use that one. Or there is a Visual Studio 2017. We have the nice feature to we can create the Docker. One moment, I will. There is a Docker support. We can create the Docker files from the uh, Visual Studio 2017. I'm creating. Just a moment. I'm going to create. I'm going to create Visual Studio. I'm going to open Visual Studio 2019. I'm creating the create the project. Okay, This is just a console application. I didn't create anything, just a console application. There is some dependency. If I build the application, it's a Docker. I'm going to add Docker support. I'm using Windows. Either I can select the Linux or Windows. I'm using Linux. Currently, my Docker engine is running on the Linux system. I can, but I can switch. It's not a problem. But I'm using Linux. It creates the Docker file. It creates the multiple multi-stage Docker file. Basic. This is a base image. Docker .NET Core runtime and SDK. Is used to build the application. After that, to run the application, we need the .NET runtime. So Docker stuff is file sharing. Yeah, I need this information. How to share the Windows file system, WSL file system to Linux containers. But it is sharing. I need to if I know this one, I need to share the volume. But let us see. It is okay. What it does? Go to the output. There is a container tools. Okay. Okay. I will run this application by using the Docker. It is building one. It already built the image, and now it is executing the container. It is now I will go to the Docker. Uh, Open and closed. Okay, just it is not doing anything. Yeah, this is one image. It created the tag dev tag, and currently it is hosted in my local. Sorry, it is running in my local. Where is containers? Yeah, containers. If you see, this is the container running in port logs. This is the logs all over. Okay, log file. If okay, um, exe minus site interactive mode. Uh, CMD. No such container. Oh, there is no that is image name. Okay. Docker. Yes. now if you see that this is the image ID. The next container. Okay. If you see that what it does, it builds the image by using the Docker file. This is the working directory app. I download the image, and if you see image, earlier this image was not there in my local machine. It download the base image. This is how much size? This is this it download the .NET runtime, and on top of .NET runtime, it build the download the SDK, and after that it build the this project, and it create the binaries, and it publish the this command. And so if I click now, I'm in this one. I'm in inside the container. I can see the solution. All the files are copied into the container. Solution file, bin file, everything copied because of this Docker file. Because of this copy dot dot. Because it copied all the current folder structure into the container, and after that it build the project, and it published the project inside the container. If you click on any command, it will be completed, a console read. And if you see that Docker file, this is entry point. It will the entry point is having the two parameters. One is the command, and one is the parameter. Which one we need to run by using this command? I'm using the .NET command to run this application. I will create another application to publish into the ACR. Just a moment. I will. Okay. Now I have this image. Now exit. I will publish into the exit. I will publish into the DockerHub. Yeah, clear. Docker images. Okay. This one. Yeah. My username slash. Okay. I created the one more tag. It will create the version. See, latest one, Rajesh Kula. Now I will push the image. Docker push. Rajesh slash. Okay. Before run that command, I will go to the DockerHub. My image, my repositories. In the I have two repositories. I don't have that repository. I'm going to push now. This is it is having 76 because of Windows Linux. If it is Windows, it is more than 500 MB. Okay, now I will switch to this one. uh, I hosted, uh, sorry, I pushed the image to the DockerHub registry. So this is the way to push the image to the DockerHub. I will create another application, and I will push the image to the Docker container registry. I will quickly show that one. I'm going. I will create the one more instance of Visual Studio. Create the application. Create new project. I will take Blazor application. Uh, Next, um, Blazor app. Create. Uh, Enable Docker support. Even if I didn't enable, I can enable later also. Uh, I'm using the Blast server. Okay, that's fine. Okay, create.
What is it, Blazor?
It's a, single page application from Microsoft.
Oh,
Uh,
okay.
it will support the WebAssembly, and it will support the server calls through Signal or
Mhm.
uh, of course still we can use the Razor uh, pages. It will support the Razor pages also. Main advantage, without JavaScript code, we can write the code and we can debug the code from the browser. We can debug the C# code from browser as well.
Nice, nice.
Uh, okay, and I create the image without Docker support. I can create the right click, Docker support. Where is the add Docker support? Um, so it is asking Linux. Target OS is, I'm creating Linux. So it's pretty much same kind of Docker file. It is take, if you see that it is building. This is multiple stages. This is one stage. This is second stage. Third stage is building, and it is export the images. All the layers are done. In this stage we have one layer, and after that it is sharing the image. I think DT volume. I think that's a remote debugger. Right. It means that read write they are sharing this volume. See users so and so volume, uh,
Mhm.
read and write with read and write permission, and another volume they are sharing. This is my local my application path they're sharing. This is the exactly Windows path they're sharing. So I can use same path. I think maybe I can try that one also. So they are sharing the multiple volumes. They are sharing multiple volumes. The source, this is the source code directory. This is user secrets. The multiple volumes they are sharing, and the environment variables also. While creating the image, they are creating the environment variables also. Okay, after that build image is created. Okay, now go to this one, Docker images, uh, Pleasure app, but it is more than it is 7 MB. Big, because base image it takes 7 MB. uh, my so now Blazor app is running okay, I will run Blazor app from local. I will host the Docker this image into the Azure Container Registry. yeah, it is going to create the certificate. Okay. Okay. So currently image is running, and port it is 32768. Application is running in my local. Okay. Now I can see the containers, docker ps, docker ps, my okay, format. This is a Blazor app created. It's running now. 32768, but it is 32768 in my local, and it is mapped to 443 secure protocol, TCP protocol, inside the container. Okay. Now I will uh, go to the docker exe minus it. What is this one? Document city. I will use Blazor app. Okay. Minus it. Actually, this is if you see the application, don't sorry, Docker file, it it copy the entire application source code. After that, it is restore the application. It build the application, and it publish the application, and it will start. The entry point is .NET Blazor app DLL. Uh, Blazor app DLL is in copy from publish to app publish dot in the current directory. It is copying app publish to current directory. So if you go to the app, there is uh, mm, mm, mm. No, it is not running from this one. It is running from this directory, uh, app directory. Yeah. It is running from this directory only, but it is copied. the projects and it is running. Okay, and now I will publish this application into the Docker container registry. I will stop and I will publish. uh, in the earlier demo I published the image to the Docker app. Now I will publish the image to the Docker container registry. Before that I will show how to create the Docker container registry from a portal. Just a moment. Mhm. Mhm. Where is that? I cannot see this word. Okay. Okay. Portal.azure. Log out. I will use the sandbox. Yeah, I can use Azure container registry. Okay. Azure container. It's very slow system. Okay, I will create from here. It's okay. Ledger app. Publish. Where is publish? Yeah. First, I will publish from publish to either I can publish to container registry, Docker container registry, DockerHub, or I can publish ACR, or I can host the application in the Azure web app. Also, it will there is option for a container. I can host the application into the web app. I can use the app service for Windows, Linux, and container. This is the app for Linux. I can use this one or container. To suppose if I use the service container, I can it will pick the container from the container the Docker registry. As of now, I didn't host it in Docker registry, so I'm using the Linux. Let us see all the possible options. I will change the that account. Next. I'm creating the new app service plan for Linux. Create. Oh, what is this? Okay, cancel. I think I don't have the permission on this account. I will switch to my account. Okay, cancel. I will switch to my account, my own account. My own account. Option. Okay, resource group. It's fine. I'm going to create the hosting plan. Create. Okay. Yeah, it is create the service plan, and I'm hosting. There's no deployment slots. I don't need. Okay, finish. Okay, finish. Okay. So I hosted the same Linux Linux app service plan. I will go to the website. Um, uh, Go to the web apps. Okay, resource groups. Which resource group taken? Oh, I didn't publish it. I have, okay, I have app service. Now I'm going to publish. Publish. It's publishing all the images, all the uh, dependencies. It is creating the file and it is publishing. Uh, it created. This is the URL. Still posting. Okay. Now I hosted by using the uh, by using app service plan. It's still posting. Now I will create the container registry. Uh, I will go to the home. I can create from Azure command line interface. In the last session, I created by using command line interface. I can create the container registry by using portal command line interface, or one more thing, PowerShell. This is the container registry. Yes. So I'm going to create the one container registry. I'm using subscription, same subscription. I'm using, I'm creating the one, yeah, I can create the one good as well. Resource group to ACR. Registry name. East to yes. Yeah, I'm using East to yes. I can, there is some pricing models, basic, standard, and premium. I'm using basic for demo. Basic is fine. Yeah, there is a public endpoints and private endpoints. Okay, fine. Encryption. Okay. Okay, I'm going to create. Okay. Yes, fine. Create. It is going to create now. It will take some time. Okay. Anyway, this site is up and running now. So if you go to the there is a web app. Uh, now I will create another container. Resource web app. Is that? It is asking the Docker container instance details. Let it be finished first of all. Yeah, it's finished. Okay, go to. Okay, I will go to the. I will go to the, yeah. And this is okay. Access con. This is a Azure Container Registry. Access keys. I'm going to enable the admin user to push the data. This is the username. I want the URL as well to push the image into the container registry. This is the login URL. Okay, so uh, security access keys, admin user. Okay, this is the admin user I'm using. Okay, now I will open the command line interface. I'm exit. Okay, agent.
Hey
Hey
Rajesh,
Rajesh,
Yeah,
hey, it's
hey,
almost
it's almost
2:30.
2:30.
two thirty.
I'll have
I'll
to
have
few
to
minutes.
few minutes.
Just a
Okay,
Just
heads
a
up.
heads up.
okay.
Yeah.
I'm going to finish in 5 minutes
Oh,
almost.
perfect.
Oh, perfect.
Okay. Okay, instead of using command line, I will use this one. Just a moment. I will use a direct portal. Just publish. I'm this one. Edit new. I'm going to use the Docker container registry. Okay, Docker container registry. Uh, yeah, I have Docker. Finish. Publish. It is now it is creating the image and it is pushing the image to the container registry. Go to the content. You can see the content. Go to in the you can see the repositories. It's building the image and it is pushing the image. It is not completed yet. It is still building the image. Now it is pushing the images to the uh, so, repository into the Azure Container Registry. Yeah, it is pushed into the Azure Container Registry. Now you can see the image. Now I will go to the uh, container instance. I will go to the one container instance, add uh, this one. Okay, I will create new one. Yes, yes. Container name. Yeah. Oh, there is a constraint. Okay. Um, I'm using this one. Okay, latest Linux. Okay, fine. Next, not public. Okay, fine. Okay, recreate. Yeah, create. So basically, container registry is to store the to keep the to store the repositories or images in Azure to avoid the ingress and egress network traffic from outside. Uh, to store the all the images in the Azure private network. And container instance is useful to run the image from Docker. Sorry, not Docker. Azure Container Registry. It will create the one instance and it will deploy. Uh, I will switch to the presentation. Uh, yeah, I think we already discussed about the Docker images we stored it locally. After that, we pushed into the DockerHub. Now we pushed into the Docker registry. Now, Azure Container Registry is a private registry to store the images in Azure network. We already discussed. And container instance, it will provide the by default it will provide the 1 CPU, 1.5 CPU. It is useful for shorter application. It will provide the per second billing model. uh, it is good for experiments and shorter application. For long run projects, it is useful. It will go for web, either web app or sorry, app service plan, or Azure Kubernetes. Azure Container Instance will not maintain the multiple containers. It will maintain the one. It will create the instance from the one container image. That is the uh, feature or drawback of Azure Container Instance. Okay, container instance is created. Now okay, this is, I think, still fully qualified name is not created yet. It is going to create. Still starting. Yeah, that's it. Anyway, it will go. It is going to start. I think we are almost I think fully qualified name is not assigned, but it is already hosted. It is running from the Azure Container Registry. Sorry, container instance. In the same way, last one. Go to the home. Okay, the app service. In the app service also, okay, there is a feature we can use the Docker image. Docker container instance. Okay, web app. AC. Docker container. Here I am using Linux. Okay, East US. East US. Then I think it's the same, pretty much same. I think this is the way we hosted from Visual Studio. Both are same. Both are. That's it from my side. Any questions or any comments? Any questions?
No, I feel
No,
it has
I
been
feel
a
it has been a
very
very
insightful
insightful
session.
session.
I was
I
zero
was zero
on Docker and
Docker and
containers.
containers.
I got a lot
I
of
got a lot of
information from this
information from
session.
this
Thank you
session.
so
Thank you
much.
so much.
Okay. Thank you, Sachin. Thank
Yeah,
you, Sudhir.
Yeah,
thank you.
thank you.
Yeah, thank you. Have a good day. Bye.
Yeah, good
Yeah,
day.
good day.
Hey, are
Hey,
you
are
recording
you
this?
recording this?
Yeah.
Okay.
Okay.
Yeah. I'll share to you.
Yeah.
Yeah. I'll share.
Okay.